myself Dr. BJD Kalyani, working as Associate Professor in the Department of Computer Science and Engineering of Institute of Aeronautical Engineering. In this video, I will discuss about black box testing techniques. The course outcomes of object-oriented software engineering consists of 6 course outcomes. The topic black box testing techniques is mapped to 2 course outcomes, CO5 and 6, explain various testing approaches and automation tools of CO5, and CO6 explain the importance of software maintenance and re-engineering process. The basic agenda of this video is: what is black box testing? What are variety of black box testing methodologies? How these methodologies can be applied to the software testing. What is black box testing is the software testing method where the tester evaluates the functionality of an application without having access to its internal code structure. So the program structure is not considered, only the user interactions with the application are considered in case of black box testing. So the internal code structure, algorithms and implementation details are not considered for the black box testing. Instead, tester interacts with the software through user interfaces, exposed application program interface treating as black box, whose internal working are not visible or known. So the program is taken as black box to which the user interactions are provided and verifies the functionality of the code. The focus lies solely on examining software's external behavior, input, output, and responses to different user actions or system interactions. So the external behavior of the system is basically verified in case of black box testing. So here the program structure, internal logic, algorithm is kept in the black box for which the input is given. So the user interactions are focused whether the expected functionality is produced by this code or not is verified with the help of black box testing. The major characteristics of black box testing are: it is independent testing. So the development team is apart from the testing team. So typically performed by the testers and are independent of the development team. Requirements based testing. Testers design test cases based on software requirements. So based on the SRS, the test case design is done by the tester without being concerned how the code is implemented. No knowledge of internal code, so testers do not have access to the source code, architecture, design details of the software. So these are hidden from the tester. The input and output interactions are majorly concentrating. So more focus and exposure on the user interfaces and APIs are considered in case of black box testing. Variety of black box testings are available. Functional testing, majorly focusing on functional requirements of the software. So the functional aspects and features of the application are verified in this functional testing. Non-functional testing, majorly focusing on the quality attributes of the software like performance, security aspects. Regression testing is retesting the application whether any change in the code produces unintended side effects. Those can be verified with the help of regression testing. User interfaces can be tested with the help of UI testing. The ease of accessing by the user with the application is verified with the help of usability testing. Without a formal procedure, informally, the testing of application is conducted with the help of inspections design documents in case of ad hoc testing, and the application is suitable for variety of environments like different variety of browsers, operating systems and hardware infrastructure is tested in case of compatibility testing. All these are the variety or categories of the black box testing. Black box testing techniques are categorized as equivalence partitioning, boundary value analysis, Gaussian table testing, state transition testing, error guessing. What is equivalence partitioning? Is kind of black box testing technique that applies to all levels of testing. We have different levels of software testing like unit testing, integration testing, system testing and user acceptance testing. At all these levels, the equivalence partitioning of black box techniques is applied. And this technique basic idea is to divide a set of test conditions into group or sets that can be considered as the same. Partitioning usually happens for test objects with include inputs, output, internal values, time-related values, and are for interface parameters. So the basic assumptions of equivalence partitioning technique are the system will handle all the input variations within a partition in the same way. If one of the input condition passes, then all other input conditions within that partition will pass. If one of the input condition fails, then all other input condition within that partition will be failed. How the equivalent partitioning process is carried out? The first step is it divides the input value into set of valid and invalid partitions. So two partitions or two sets are majorly focused, valid range and invalid range. The valid partitions are the values that should be accepted by the component or system under test. This partition is called valid equivalence partition. All these are the valid input for the valid partition. Next, invalid partition are the values that should be rejected by the component or system under test. This partition is called invalid equivalence partition. So, the input values must be categorized into valid equivalence partition as well as invalid equivalence partitioning. Consider with an example, we will discuss this equivalence partitioning. In an application where you are filling an online application for a gym membership, the application can have generally the basic information, that is age, name, gender, address, like this. So what are the most important criteria for getting a membership is the age. Most of the gyms have age criteria of 16 to 60. So where you can independently get the membership without any supervision needed. If you look at below membership form, you will need to fill the age first. So this is the gym membership filling form. In this, the first information need to fill is the age, and the allowed independent group of age is 16 to 60. Without any supervision, these members can get the gym admission easily. So if we have to test this age field, generally we can recognize that the valid age range is 16 to 60. How can it is easily to figure out? But what is not very evident, how many combinations we need to test for this functionality to work safely. So here we are having the possible combinations are less than 16 has 15 combination. Age is 16 to 60 range. Here there is a combination 15 combinations of age which is having less than 16. So 0 to 15 range must be validated in this category. And another range is 16 to 60. This is a valid range to fill the form, has 45 combinations to test. And greater than 60 having 40 combinations to test to full-fledgedly thoroughly test the application. The 15, 45 and 40 total of these combinations and test cases are designed to test the application. But with the equivalence partitioning, more than 100 combinations we are testing. So to minimize the number of test cases and to maximize the test coverage, in this scenario, the equivalence partitioning can be used. So here in the equivalence partitioning, we are grouping that invalid partition, that is 0 to 15 is the invalid partition and 16 to 60 is the valid partition. Greater than 60 are the invalid partitioning. So we are dividing the input range into invalid and valid partition. Here in our case, the invalid partitions of combinations lies between the range of 0 to 50 and 61 to greater than 60 are considered as the invalid partition range. And the valid partition range is 16 to 60. So that here the number of test cases are greatly reduced in order to test the valid range as well as invalid range. So instead of 100 plus test case combinations to test the maximum text coverage, here we can write the test case design to test this valid partition range, invalid partition range, valid partition range, again invalid partition range. With the help of 3 test cases, the maximum test coverage is accomplished with the help of equivalence partitioning. So, for example, if you consider the age is 5, enter age is 20, enter age is 65. 3 combinations, 3 input values for the age is taken as an example. Then entering the age is 5 is falling into this category, which is an invalid partitioning, and valid partitioning is 16 to 60. So next 65 is falling in this category. And if this range is very greater, sub partitions can also be done so as to cover optimized code. Maximum coverage of code can be done in case of equivalence partitioning, so that we can have more classes, subclasses VP1, VP2, VP3, and you can write the sample test cases in order to test these sub-regions also. What are the advantages and disadvantages of this equivalence partitioning methodology? The advantage is it is process oriented and can achieve with minimum number of test cases. We can cover maximum test coverage and degree of general test execution time and decreases the test execution time. The disadvantage is it is all necessary inputs may not be covered. So this technique will not consider for conditions. So only category of valid invalid ranges are focused, For conditional checking, there is no facility. The test engineer might assume that output for all dataset is right, which leads to the problem during the testing process. So these are the disadvantages of equivalence partitioning method. Another variety of black box testing technique is boundary value analysis. Boundary value analysis is one of the widely used test case design technique under the black box testing. So here it is used to test the boundary values. Why? Because boundary values are more error prone. So boundaries are concentrated. More test case design is concentrated with this technique on the boundary values. Boundary values are those that contain the upper and lower limit for a variable. If you consider these are the boundaries for a variable. And boundary value analysis involves software testing data near to the specified limits. So near to the boundaries upper limit and the lower limit specifications. Minimum and maximum values, test inputs at near the defined minimum and maximum limits are considered. Default values are the test default values when no input is provided. Edge values are the test input, right on the boundaries are the edges. Invalid values are the invalid inputs to check for proper error handling. So here by taking a scenario as an example, the boundary value analysis testing technique can be analyzed. So here testing a software application that calculate discounts for online purchases. So the application provides the discounts based on the amount of the purchase and has predefined discount tiers. In the tier 1, 0 discount for the purchase less than $10. In the second tier, 5% discount for the purchase from $10 to $50. In the tier 3, 10% discount for purchase of $50 to $100. Tier 4, 15% discount for purchase of $100 and more. So boundary value testing the lower boundary of tier 1, that is the input is $9.99, expected output is 0 discount. Why? Because for the tier 1, 0 discount purchase less than the $10. And boundary value 2 testing the upper boundary of the tier 2. So the input is $10. So expected output must be the 5% discount. And boundary value 3 is testing the lower boundary of the tier 3 and the input is $50. Expected output must be the 10% discount. And boundary value 4 for testing the upper boundary of tier 3. So $100. So expected output is 10%. In the boundary value 5, the lower boundary of tier 4 is tested with an input value of $100.01. So the expected output must be the 15% discount. In case of next test case design of boundary value 6, testing the upper boundary of tier 4 with an input of $1000. So expected output must be the 15% discount. So like this, the boundary values must be tested more carefully in case of boundary value analysis testing technique. Another testing technique in the black box is the decision table testing. Decision table testing is widely used to design the test cases under black box testing methodology. So this is a systematic approach where various input combinations and their respective system behaviors are captured in a tabular form. That table is called the decision table. Decision table technique is appropriate for the functions that have logical relationships between two or more than two inputs. The technique is related to the correct combination of inputs and determines the result of various combinations of input. So here is the template for the decision table. Majorly it can have 4 parts: condition step, condition entry, action step, action entry. Here the list of conditions must be specified and list of actions are specified. Each condition is evaluated vertically in case of condition entries and action entries. So here we can use a test case scenario that we can use an email account. When you want to use an email account, for this you need to enter the email ID and associated password. If both email ID and password are correctly matched, then only the user can be access the email account homepage. Otherwise, he is rejected and an error message is specified with incorrect email or incorrect password. So the decision table to this scenario is email condition. If the username in the email is correct and the password is also correct, then the expected result is account page must be displayed. So here the conditions, 2 conditions that are going to be tested are listed here in the conditions tab. This is the action that can be implemented based on the condition matching. So here email is tested true and password is also tested true. Then the expected result, the user can access the account home page. If email is true and password is false, then incorrect password and error message must be displayed. In the next test case, if email is failed and password is true, incorrect email is displayed an error message. And the last test case design here to consider the combination of email false as well as password is also false. So the error message, incorrect email message can be displayed. In this way, decision table testing technique can be applied. The next variety of black box testing technique is the state transition testing. State transition testing is one of the kind of black box testing technique in which changes are made in input conditions cause state changes or output changes for the application under test. So state transition testing is very helpful to analyze behavior of the application for different input conditions. Tester can provide positive and negative input test values and record the system behavior. So the dynamic behavior of the application is easily verified with the help of state transition testing. So we consider an example of ATM. When withdrawing money from the ATM, it displays account details at last. Now we again do another transaction, then it again displays account details. But these displayed after seconds. Transactions are different from first transaction. But both details are displayed by using the same function of the ATM. So same function was used here, but each time the output was different. This is called state transition. In this case of testing a software application, this method tests whether the function is following state transition specifications on entering different inputs. So here the ATM behavior is easily captured with the help of state transition. So here this is the start state. On the first try, if it all correct pin is entered, then access is granted. On the first try, incorrect pin is entered, then it leads to the second try. At this stage, if the correct pin is entered, then access must be granted. And at second try, if incorrect PIN is entered, then it leads to the third try. At this stage also the user enters incorrect PIN, the account can be blocked. Like this, with varied input, how the system state can be transitioned, that can be easily tested with the state transition testing. So here the test cases can be designed that the first attempt, the valid input, and it is redirected to the second attempt. Invalid input, it is redirected to the second attempt. In the second attempt also invalid input is entered, then it is redirected to the third attempt. In the third attempt also invalid, then the account must be blocked. The last method of black box testing is error guessing. So here, in which there is no specific method for identifying or verifying the errors. It is based on the experience of the test analyst. So the expertise of the test engineer is considered, where the tester uses experience to guess the problematic areas of the software. It is a type of black box testing technique which does not have any defined structure to find the error. So here in the error guessing, the tester intuition or experience can be considered. Historical learnings is more important. Risk reports of the software are major base for the testing. Application user interfaces are considered. General testing rules, previous test results are the basis for the test case design. Defects occurred in the past and historic data plays an important role, and variety of data which is used for testing and knowledge of application under test, the domain knowledge and tester expertise is crucial for error guessing testing technique. So the purpose of error guessing is to deal with all possible errors which cannot be identified in formal testing. So it must contain all inclusive sets of test cases without skipping any problematic areas and without involving redundant test cases. So the test case redundancy is greatly reduced with the help of error guessing. This technique accomplishes the characteristics of left incomplete during the formal testing. So for what is error guessing? With an example, we will examine a function of a application requires mobile number and which can generally should have 10 characters. Now below are the techniques that can be applied to guess error in the mobile number field. So with the expertise of test engineer, with the domain knowledge, the test engineer can write and consider these conditions while designing the test cases. What will be the result if the entered character is other than a number? Next, what will be the result if entered characters are less than the 10 digits? What will be the result if the mobile field is left blank? So with the domain knowledge and tester expertise, he can design these test cases. So in this video, I discussed what are various black box testing methodology, especially the equivalence partitioning, boundary value analysis, decision table testing, state transition testing, and error guessing mechanisms, how they can be applied with examples. And these are the references used in this video. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.